Now, in this lecture, we're going to talk about perceptual development and we're going to talk about motor development, and we'll spend a little bit time on learning. How do infants learn? Okay, now what are some of the difficulties when we are trying to measure the infant's perception? Okay, so the difficulties are, of course, we know that babies sleep a lot, as we said before. The newborn, they're about sleeping about 16 hours in a day, and then and other times they are going to be spending a lot of time crying. Another one is like you don't know if they're paying attention to something, and the last one is because they don't understand the language yet. They are unable to communicate with them, with you, and then you're also not able to communicate with them. Okay, so these are all the difficulties that we have when we are trying to measure infant perception. So what are some of the things that you can use to look at infant perception? So one of the techniques that they use is called preferential looking. So what is preferential looking? It is basically the way that you are looking at um, something, and then when you get very used to it, when you get habituated to it, you are actually going to stop paying attention to it. But then now when we present something else that is new, now because this is new, you're going to pay more attention to it because this is something that's new. You are not familiar with it yet. Infant as well as animals, they all have this property. They prefer something that is new. They are going to spend more time investigating something that is new. Okay, so this is the method that they use in preferential looking. So for instance, they are going to allow the baby to look at this until he or she is tired of it. And then they're going to introduce something that is new, that say this. And then now the baby is going to spend more time looking at this object because this is new. Okay, and then this is the way that they can tell for the scientists that this previously paid attention to object is new, it's different from this thing that was presented later. Now, on the other side, if the infant spend the same amount of time looking at both objects, then that means the infant is not able to tell the differences between the two objects. Okay, and they use this preferential looking method very often when they are looking at the infant's perception. So with this preferential looking method, what the scientists can really determine is that they can really try to see whether or not the infant can really tell the differences between the two visual stimuli. Okay, so for instance, what you have here on the left, this is like a visual stimuli with a bunch of stripes, right? And then on the right, what you have is a bunch of just like a graded kind of like texture, right? And then so if the infants are not good at telling these two apart, then let's say when the novel stimulus is this one with the stripes, then the infant is not going to spend that much more time looking at this stripe stimulus, which is the novel stimulus. Okay, so what do the data actually look like for a typical preferential looking experiment? So this is what the data actually look like for the habituation part. Okay, as well as the dishabituation that we'll talk about later. So on the y-axis, what you have is the looking time. Okay, this is the amount of the time the infant is spending looking at the visual stimulus. Okay, and on the x-axis, what you have is the order of the trial. So this is the first trial, this is the second trial, this is the third trial, and so forth. Okay, and you can kind of see that is that as the number of the trial goes on, the baby with the infant, they basically start to lose their interest. Okay, because you can see that the first trial, they spend a lot of time looking at at the stimulus, right? And by the fifth time or the sixth time, you can see that there is a downward trend here, that they're not spending that much more time looking at it anymore. That means what? That means that they get bored with this stimulus that is repeatedly presented to them, right? Now, what happens now if you were to give them a new stimulus that is in this line over here? So what happens when you give them a new stimulus? What you can see is this term called dishabituation, okay? Because this is a novel or a new stimulus, okay? And that means that now what happens with the old stimulus or a familiar stimulus, you can see that there is continued habituation, okay? But with the new stimulus, with the novel stimulus, what you can see is dishabituation, okay? So that means that if the infant can spend more time looking at this novel stimulus, that means they are able to tell apart the differences between the previously habituated stimulus versus the novel stimulus, okay? Now, for the rest of the lecture, for the perceptual capabilities, let's take a look at what happened to these aspects when it comes to acuity of contrast, the objects, the color, the depth, and movement and hearing, okay? And later on, after all of these, then we'll talk about motor activities. Now, scientists have measured the visual acuity for the infants when they're developing, and you can see that at 1 month of age, their visual acuity is about 20 to 400 to 20 over 600, okay? Now at 6 months of age, they are just below perfect vision, 20/20, okay? And then after 1 years of age, then the infants, they are able to reach 20/20 vision. And down here, what you're looking at is the actual evoked visual potential. So visual evoked potential, VEPs, okay? So what is VEP? Well, the VEP is kind of very similar to EEG, but then what they're looking at specifically is they have the electrode stick to the occipital pole that's close to the infant's the back of their brain. And then so they're looking at the activity of the visual cortex. Okay, and on top of that, they are only looking at evoked potentials, which means that they are going to present a visual stimulus to the infants, and then they are going to take a look at what are the actual response for the visual stimulus evoked potentials. So this is why it's called VEPs, okay? And so they're not really looking at just spontaneous activities, but they're looking at visually stimulus evoked potentials, okay? And what you can see is that the visual evoked potential correlates with the visual acuity, because basically when you look at all of these, something I want to say is that each dot here is basically a data from one person, okay? And then, so this is this is person A, their age is 3, and then their visual acuity is at certain places and stuff like that. And basically you can see that this is a straight line, okay? And which means that the visual acuity and the visual evoked potentials is really strongly correlated. And what is the anatomical underpinning or like the brain development correlate with that? Well, that is actually something that we have talked about before. And when you look at the Golgi staining in the newborn versus the 3 months old versus the 6 months old, you can see that their cortical development in the visual cortex when it comes to the simplicity or the how elaborate the dendrites are, you can see that the newborn, their dendrite is much more simple compared to the 3 months old compared to the 6 months old. So when they get to the 6 months old, the complexity of the dendrites in the neurons in the visual primary visual cortex is very complex. Okay, and this really is one of the many reasons why the acuity is really improving when the infant is developing. Okay, and because now there are much more dendrites and dendritic spines to really help to segregate the differences from the environment when it comes to the inputs. Now, another reason that contributes to this enhanced visual acuity when it comes to the development is really the cone size development. Okay, now when we look at the cone size, let me just kind of back up a little bit. So the cones are the actual retinal cells that is in the back of the retina. Okay, so in the retina, what you basically are looking at the amount of the cells, the photoreceptors that are responsible to really accepting light. Okay, now let's take a look at the size of the newborn cone receptors. Okay, you can see that the cone receptors for a newborn is this big. Okay, the area that it takes up is very, very big here, right? As opposed to an adult cone, the area at the surface is really very small. And when we look at them from a bird's eye view, then what you're basically seeing is that the newborn lattice for the cones are, is like this much, okay? And now, given that if the area is about the same, how many cells can you pack here? You can only pack 10, right? But in adults, what you can see that here, I mean, the area in the adult what you're seeing is slightly less than the newborn, but there is well over like probably like more than 100 of cones in there, right? So what does this mean? That means that when you have such high density of the cones in adults, you can segregate the source input much more easily, which also means that the visual acuity is enhanced in adult much more compared to the newborn. This is the second reason why the acuity is so much greater when the infants start to develop, because the size of the cones gets smaller and smaller, and then the density of the cones that occupies the same areas on the retina becomes much more much higher as well. Now let's take a look at the contrast, okay? Now you're probably thinking that, what do you mean contrast? Well, contrast is a way that we can really see contours in life. Okay, so contrast is a good way to kind of see how sharp the edges are. Can you tell like the differences, or with the stripes, or can you not tell the differences with the stripes that easily? Now, as adult, we are very good when we are looking at the contrast. You can see that the contrast sensitivity is very high, right? And then, but when you look at the infants, the 1 month old is the lowest, and then the 3 months old, there are some improvement, right? But then, they're nowhere near adults. Now you're probably thinking that, I mean, this doesn't really make that much sense to me. What does it really look like? And this is something that we have seen before, and I'll show you this in the next slide. Okay, so they've done simulations of what the infant would look at the mother, and then what the mother would actually look like at each different stage of the infant's life. You can see that at 1 month, what they can see is that you can kind of see the hairline. You can you can see the differences between the face and the hairlines, right? But you can't really see much more than that. You can kind of see that this is a person's face if you're very good at imagining. Okay, now at 2 months, you can definitely see that this is a person's face. You can see the hairline. You can see what is a face. You can tell that there are some eye features, and maybe you can tell that this might be a nose uh, and the mouth and stuff like that, but still not much of a detail still coming in. But at 3 months of age, you can start to see that much more details become to fill in. It becomes much more clear. Okay, and in adults, as well as we said before, at 1 years of age, the infants, their vision are as good as adults. All right, so basically, this is also at 1 year of age. And you can see that at 1 year old, as well as and when they're adults, that they can see it like this. This is as good as they usually see it. Okay, so this is what the contrast really kind of helps the, so this is how the infant really see the differences in contrast compared to adults. That's what I mean. Okay, what about object recognition? So what they do is they have something called the figure ground segregation by motion. Okay, so basically, this thing on the right, okay, this thing on the right, so that the part that I am really trying to put it in the green, they are going to move this back and forth in a background. Okay, and then they're going to make the infant habituate to this, and then they're going to change to this, or they're going to change to that. So you're probably thinking, what does this mean? Well, that means that does the infant, can they really recognize the figure by ground segregation by motion? Okay, and now if they dishabituate to A, that means that A is not, they see A as different as this original figure that was habituated to, right? Now, if they dishabituate to B, that means that they saw this previously habituated object and B is completely different. Okay, and this is something that they can really do when it comes to segregation of objects. And another thing that what they can do is they can look at perceptual grouping. Okay, what is perceptual grouping? And perceptual grouping is when you look at something on the left here, perceptual grouping is most likely you are going to see this as a white bar and the black bar followed by a white bar and the black bar. Okay, and then they can have the infant habituate to this object on the left, and then they are going to change them to either this or this. Okay, now if they continue to habituate to this, that means that they were able to see this bottom one with the four vertical stripes as the same object as the one that they're habituated to. Okay, so that means that, basically this is a way to see if they can tell if they see this as exactly the same or they don't. Okay, and you can see that at 3 months of age, at 3 months age, basically the infants, they start to group this thing on the left exactly the same as this. Okay, which means that at 3 months old, they are able to perceptually categorize things by lightness. Okay. And another thing that what they can do is object occlusion. Okay, so what is object occlusion? So the stimulus, what they have the infants habituate to is the raw movement. Okay, So there is a rod. We don't know if the cover part is segregated or is it part together. Okay, and that's the point. Okay, so they're going to have the simultaneous movement of the top portion of the rod and the bottom portion of the rod together. Okay, so when the top moves to the right, the bottom is going to move to the right and also to the left. Okay, and then they're going to habituate the infant to the stimulus on the left, and then they're going to change the stimulus to either two separate rods or one complete rod. Okay, now so the idea is that if the infant continues to habituate to this one rod, that means that the infant really saw this original stimulus with the rod movement the same thing as this one rod. Okay, does that make sense? Okay, so basically now if the infant keeps continue to become habituated to this two things, that means that the infant saw this original rod as two separate entities. Okay, now, so what happens with the infants is that at 4 months of age, they were able to really see this raw movement as the same as this one whole rod. Okay, so that means that this movement grouping development capability really is pretty much developed by this 4 months of age. Now, what about object segregation? Okay, now what is object segregation? So the object segregation really is about, can the infants really tell that these are two objects that are just really close to one another, or do they see this as one object altogether? Okay, so the example that they have here on the left, what the infants are being habituated to is duck sitting on a truck. Okay, and then so they will have the infants become habituated to this image. Then they are going to change it to the guy taking away the duck and was able to pick up the duck, or the image where the guy is picking up the duck and then the truck goes along with the duck. Okay, now if the infant keeps becoming habituated to this, what does that mean? That means that the infant saw this object on the left as one entity. Okay, now if the infant becomes habituated to this, what does that mean? That means that the infant saw these two things as the same object, well, as same two objects as this. Okay, and now what they find is that the infants, they were able to segregate the objects at 10 months old, okay, as it says here. Okay, so basically that means that the infants, they are able to tell that this picture on the left really is the duck sitting on a truck. Okay, only starting at 10 months of age. Now, as opposed to object segregation, the infants, they can tell the differences in color much quicker than much younger age than object segregation. Okay, so what they did is so over here they habituate the infant to wavelength of 510, which is still under the green. Okay, and then they are going to change it to 480 or 540. Okay, now 480 is much more in the blue spectrum, as you can see, and then 40 is much more in the green spectrum. Okay, so what happened is that at 4 months, the infants, they are able to tell the differences between green and blue already. Okay, and that has to do with the actual development with the proportion of the different kinds of rods and cones. I mean, it's a lot of psychology and a lot of perceptions in there. I'm not going to get into too much in detail. Later on, if I open up a course on perceptual processes on vision, then you guys can take that with me. But right now, you just have to remember that the infants, they can tell different shades of green and blue at around 4 months of age. Now, as opposed to they were able to tell the difference between blue and green around 4 months of age, they're able to tell a different, they're able to tell the lower wavelength colors at a younger age. So for instance, what we are seeing here is they can tell the long, medium wavelength discrimination of about 3 months of age. Okay, and what is the reason for that? The reason for that is that we have different distributions of the L, the M, and the S cones. All right, long standing for, I mean L standing for long, and M standing for medium, and S standing for short. And the proportion of the long cones in the retina is much more compared to the medium, and which is a lot more compared to the short cones. So now the short cones are responsible for processing the blue wavelength, so the higher or the shorter wavelength colors. And the long cones are more responsible for processing the longer wavelength colors, such as red. Okay, so let's just give you some examples. They have done a lot of psychophysical experiments in which that adult humans can tell the differences between about 200 shades of red, okay, ranging from like purplish to very like orange-ish shades of red. But human beings are only able to discriminate about 50 shades of blue, right, ranging from like a blue-green blue to like a very purplish blue. Okay, so what that means is that, and the reason for that is because the distribution of the cones that you have in the retina, we have much more L cones with the long cones that we have in our retina that are responsible for processing the longer wavelengths, such as red color. Okay, and you can see that because the infants, they have more of these red with the L cones, they're able to discriminate longer wavelength colors at a younger age. Now, what do they do for depth discrimination when it comes to testing the child, well, with the infants, the babies, okay? So the way that they do this is slightly different. They basically look, they basically would put an object in front of the babies between two eyes, right? And then they will move the object either away or toward the baby, okay? And then now if the baby can really see when they're trying to focus on this object, then as the object is moving away, the eyeballs, they're going to diverge, right? You can see that the eyeball, the left is gonna go this way, and then the right eyeball is gonna go this way. Okay, now when the object becomes closer, then the eyes, they're going to converge and it basically becomes cross-eyed. Okay, and now it turns out that the depth, the binocular disparity for discriminating depth is very good for the baby. And then this is pretty well developed at 1 to 3 months months age of they're developed at 1 to 3 months. Okay. Now let's talk about hearing. How do they test hearing? Okay. Now, like we said before, that the infants, they really like new sounds, right? So when there are new sounds that is kind of going out, the infants, they're gonna turn their head, right? So this is exactly what they do. They would test the baby's hearings, and then they're gonna see how often they are going to turn their heads. And you can see that babies, they have about 72% of the time that are going to turn their head toward where the sound is happening. Okay, now rarely they would turn away from the sound, and even more rarely they would not turn the sound at all. Okay, this is how they test the hearing. And what the scientists can do is they can test the hearing in terms of the frequency, okay? Frequency meaning the pitch, okay? So if someone who has a very sharp, very screechy voice, they talk very high, that means that the wavelength is very high. You're looking at about like this range, okay? And then and what you can do is also look at when someone's talking very, very low, and then they're really talking about like this range. Okay. Now, what I want to bring out is that, so on the x-axis, what you're looking at is the frequency of the sound waves. Okay. And on the y-axis, what you have is the decibel, is how loud it is. Okay. So the amount of the vibration that a certain object is causing. And then, so what we basically are looking at is that adults definitely have basically, well, as you suspected, much better hearing than infants, okay? And meaning what? Meaning that adults, you can see that there is this curve on the bottom, okay? So they're much more sensitive in the hearing compared to the babies, okay? And which means what? For the adults, you don't need very loud noise for them to detect some sort of sound, okay? But at 6 months of age, you can see that they're not very good. I mean, at least compared to the adults, they need the sound to be significantly louder for them to detect them. And at 3 months, you have to talk even louder, or you have to make the sound stimulus even louder for them to respond to the sound. Okay, so you can, so basically what we have, what we know is that even we know that the hearing in the infants develop faster than the vision in the babies, but compared to adults, there is still a lot of the postnatal development that are happening. Now let's take a look at motor development now. Now, compared to perceptual development, uh, looking at motor development is much easier even to like a non-scientist. And here is like a list of what the babies are able to do when they are in different ages in the first like 15 months of their age. So you can see that at when they're born until about a little bit before 1 month, they can prone, they can lift their head, right? And starting from 2 months, you can see that they can prone, they can bring up their chest, they can use their arms for support, right? And then, and then a little bit after that, they can start to roll over, right? So these are all like developmental key stages when it comes to development, okay? And then somewhere between 3 months and 6 months, they can start to have some support of their legs. And, and then from somewhere between 4 months to 7 months, so to speak, they can sit without support, right? And then a little bit after that, now they can stand without support, with support, okay? And then after that, they can pull themselves up to stand, right? So this is something that's very major. So before this step, with standing with the support, the parents or whoever who is taking care of the baby needs to help the baby up and then have their hands against something, let's say a wall or a chair or something like that, for them to really stand with the support, right? But now, but then the stage after that is that they can now pull themselves to stand. And now the next stage is they can now walk using furniture for support. So these are like the training walkers that you guys may have had, that have like a safeguard in between, and then the height is adjusted to right to the point that the baby can either sit or they can use their legs to walk around. So this is the key stage really to train the child for walking, okay? And then after that becomes the magic stage, and that is standing alone easily without holding on to any furniture, okay? And then after that, then they start walking alone easily, okay? So this is basically the proper motor development of an infant during the 15 months, the first 15 months in their life. Now, are there ways to kind of promote the motor development? Right now, in many cultures, they really actively encourage their infants' motor development. So, for instance, there are a lot of like cultures, including West Africa, they would employ these motor exercises that includes massage, limb manipulation, and other forms of motor stimulation to kind of enhance this motor development. Okay, and you see this in not just one country, but in many countries. Okay, now your textbook lists them. I'm not gonna list them here, but then they range from like Sahara, Africa, basically. Okay, and so these motor stimulation, as you can see here in this picture, they are often accompanied by other things like singing and bouncing, and also very happy like affirmations from the caregiver. And then now they're also chosen intentionally to promote their infant's motor development. Okay, so you can see that there are stretching. Okay, there are things like suspension. You hold the baby up by one arm or both legs, and a lot of these things. So they believe that these are going to stimulate like the muscle growth, and this can also, when you kind of think about what we talked about in terms of the enrichment, this really is enriching the motor as well as some somatosensory activities that's in the babies. So with this help, I think so. You can try this with your babies. I mean, of course, you want to do this with supervision, and you want to do it correctly. Later on, if you do have your child, you might have your children develop earlier and then have a stronger body, and you can maybe train them to be the next Olympian for China, okay, or for whatever country that you're in, okay. Now this is another very interesting study in which they actually ask this: the wearing diapers, does that actually influence walking? So it turns out that the diapers actually do influence walking. So you can see that when they give the babies like a very clumsy diaper that is cloth, their footprint pattern is like this. It's not anywhere close to a straight line, right? Now, when they give a lighter disposable um, diapers, you can see that the infant walks more like a straight line. Now, when they do not give the diapers to the infant, you can see that they're really walking very much like a mature adult would walk. So that means that these diapers are really actually hampering or hindering the ability for these infants to walk well. Okay, now would I recommend that you don't give your children diapers in the future? I mean, that's not what I'm saying, because they would just pee everywhere, because at this age, then they're not well potty trained yet. So this is not a good idea just to let them run around the house naked uh, at this age. Maybe after they're potty trained, then yes, but then by then they don't really need diapers, right? So anyway, so that's kind of like a moot point. Now let's talk about learning. Learning can really happen in many kinds of forms. So there can be habituation, there can be perceptual learning, there is the classical conditioning, and also the instrumental learning. You might also know it as the operant conditioning. And there's also observational learning or imitation, rational learning, and active learning. So we'll briefly go through all of these and kind of talk about them in the context of development. Now, we have talked about habituation already, right? And habituation is basically what happens to the baby when you keep presenting exactly the same thing over and over and over again, and eventually they became bored with it. Okay, and this is exactly this is like a very good picture demonstration of the baby's emotions and their interest while they're looking at uh, basically a stimulus. Okay, so this is so this picture over here, that is them. This is the baby. The first time we're looking at the stimulus, you can see that she was she. I think it's a she. I think that she is a very focused looking at the screen. Okay, and then the second time when the same stimulus was presented, you can see that she was still interested in that. Now, by the third time, you see that you start to become disengaged a little bit. And the fourth one, she starts yawning, right? And the fifth time, she's not even looking at the screen anymore. And then at the sixth time, that this baby is basically not even paying attention to the screen, right? Now, when they reintroduced a new stimulus that was different from the one that was habituated to, what happens? She becomes engaged at the screen again. You can see that she was very happy. Say, oh, what is this? This is something new. Okay. So which means that there is a significant amount of habituation to the repeatedly presented stimulus. So that means what? That means that this baby has learned that this is something that I've seen previously. And then don't keep showing it to me. I am not interested in it anymore. I became familiar with it. Okay. So this is one of the earliest and the easiest form that we can look at in terms of learning. Now let's talk about perceptual learning. Okay, now what is perceptual learning? This is something that is more specific to infants, and perceptual learning is learning just by watching and paying attention to something. Okay, and there are two main aspects or the key main processes when it comes to perceptual learning. So one is differentiation, and this is really extracting the relationship that remain constant from the ever-changing environment. So so for instance, the infants, they really learn the association between like the tone of voice and facial expression. And so because in their experiences, like different kinds of emotions, it can be kind of associated to one another kind of voice with a smiling face and not a frowning one. So this is a way for them to really become to have to be able to extract relationship that really kind of remain constant, right? So for instance, when someone is happy, they always have a smile face, and their voice is always more singing song. Oh, hi, how are you? That kind of voice. And when someone is sad, regardless of the actual changing environment, they will always have a frown on their face, and they will always be down and be like, oh, I'm not feeling so good. I'm in the bad mood. Like that. Okay. And so that is differentiation. They learn to differentiate all these different things, and they were able to extract the things that are constant despite the environment changing. Okay, so if you are happy in New York, that is still, and versus when you're happy in Seattle, versus when you're happy in Beijing, versus when you're happy in Hong Kong, you're still happy despite the fact that your relationship into the environment is changing, but your happiness still remains the same. Okay, so they learn to learn this. They basically learn to associate this with some sort of perception. Okay, and now the next key process really is affordance. So this is the possibilities for action offered or afforded by objects and situations. Okay, so for instance, the 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 small objects, they have the possibility that they can be picked up. Okay, and then things like the liquid affords the possibility of being poured and spilled. Okay, and then the chairs affords the possibility of being sat on, and so on, so and so forth. So basically, so the infants, they really discover affordances by figuring out the relationship between their own bodies and abilities and the things around them. And so in other words, they don't really start to learn on these by until they can actively engage with the environment. Okay, so let's say if they cannot even reach out to certain things yet, then they don't really know the fact that this thing can be picked up. All right, so if they cannot approach the chair, if they cannot even stand up in the first place, they don't really know that a chair can be sat on without them falling onto the ground. So this kind of stuff. Okay, so you can see that a prerequisite for perceptual learning really is this ability to interact with the environment, as you saw before in the motor learning processes. Okay. Now, the next one is classical conditioning. This is something that you guys probably learned in your Psych 101 class. So I'm just kind of, but I'll tell you what it is anyway, in case you have not learned this. So basically, classical conditioning was found by Ivan Pavlov, and now before the conditioned, they are going to give the food, which is the unconditioned stimulus, the US, okay? And then what does the dog do? Well, the dog see the food, they know that this is tasty, they start to have an unconditioned response, and that is salivation. They start to drool, they start to say, "Ooh, yes, this is very good, this is tasty, I want it, I want it," okay? And then what they're going to do, and then so that's the first thing. So we have a unconditioned stimulus and we have an unconditioned response. All right, now at number two, what we're looking at before conditioning, we have a bell ring, and this is a neutral stimulus, right? Now the bell ring, what is that? There is no condition with no unconditioned response. You got no salivation at all, right? So what do they do during the conditioning? So they are going to pair the bell ring with the food all the time, okay? Now, what happened is that the dog sees the food, right? And then the dog at the same time hear the bell while he is eating the food, okay? And then what is going to happen is that this dog is going to have unconditioned response, which is salivation, okay? Now, after you pair the bell and the food for like a lot of times, let's say 20 trials or maybe 50 trials, something like that, for a long time. And then now you ring the bell only without the food being present. Now you can see that the bell is able to elicit the conditioned response, which is salivation. Okay, so now the bell after conditioning becomes the CS, the conditioned stimulus, and then the dog is going to have the conditioned response, and that is the CR, basically. Okay, now you're probably thinking that, well, so what does this have to do with baby? Okay, well, it turns out that classical condition is also displayed by newborn infants. So one classical conditioning task used with newborns is eye blink conditioning, in which a tone CS is paired with a puff of air, so unconditioned stimulus to the eye. So this is going to elicit an eye blink. Okay. Now after exposure to the paired tone and the air puff, the infants will begin to blink in response to the tone alone, which is the CR. Okay. So you can see that infants you are able to elicit some sort of innate learning in the sense of classical conditioning. Now let's talk about instrumental conditioning. You might also know it as operant conditioning. Now this is different from classical conditioning. Okay, classical conditioning, what we are trying to do is basically only trying to make a new association for the animals or for the baby. Okay. Now, instrumental conditionings is you're not trying to make them make a new association. What you're trying to do is to do behavior modification, in which that you can change the behavior by teaching the animal or a human in our case. Okay, you can teach them to modify their behavior. You can change unwanted behaviors, and you can enhance wanted behavior from the children. Okay, so how does operant conditioning work? Well, operant conditioning work by using reward and punishment. Okay, and rewards are basically just they introduce them to increase a certain behavior that is wanted, and punishment is used to decrease a unwanted behavior. Okay, now there are different kinds of rewards and punishment, and you see this in the following slide. Now we're talking about reinforcement and punishment. Okay, so reinforcement, you can think of it as reward as well. Okay, so what is a positive reinforcement? All right, so basically reinforcement is what we want to do when we want to increase the frequency of the desirable behavior. Okay, so positive reinforcement will be something like you give them a reward for doing something good. So for instance, if your child got 100 and then you tell them that this is very good, I'm going to give you $100 for 100 yuan for this as your reward. Okay, so that is a positive reinforcement. You gave them, you apply a stimulus for their good behavior. Okay, and therefore you have positively reinforced your child. Okay, now what is negative reinforcement? A lot of people mistaken negative reinforcement as some sort of punishment, and this is not true. Okay, negative reinforcement is when you remove something that is undesirable for your child. Okay, so for instance, your child hates doing the dishes after dinner. Okay, and then now your child came home today with like 100 on his test, and you tell your child that, oh, great job, you don't have to do the dishes tonight. Okay, you removed something that they do not like. That is still a reinforcement, but you basically removed the stimulus that they do not like. So that is a negative reinforcement. Okay, now let's talk about two forms of punishment. Okay, now you have, so punishment, the role of the punishment is basically to decrease the frequency of the undesirable behavior. So let's say if your child is misbehaving, they're crying in front of people, and that is something that you don't like. And what you can do if you want to do a positive punishment, or a lot of people would just say punishment, okay? And you can hit them. Of course, I don't recommend you do that. And you can yell at them, okay? You apply some stimulus to their negative behavior. That's a punishment, okay? Now, I have to say punishment don't work very well, okay? And reinforcement or rewards work so much better than punishment, okay? Or what you can do is you can do negative punishment, or a lot of people will call this omission, okay? And what is negative punishment? It's basically you remove something that they love, what they like, okay? So for instance, if they come home with a 60 or a 50 on a test, you tell them that, okay, you cannot watch TV tonight. You have to study. Okay, that is a form of you just took away the TV time, okay, plus you gave them something. So this is, in that case, that's really like double punishment. You took away something they love, which is watching TV, and you gave them something they not love, which is a positive punishment. Okay, so that is a double punishment basically. Okay, so that well, that may work, but then they may really hate you anyway. All right, now let's talk about observational learning. So what is observational learning? It's basically how people learn to imitate the behavior of other people, and they can do this in pretty early in life. And now over here, what we have is a cartoon that two non-Asian people, they're basically trying to figure out how to use the chopsticks. And now they watch other people how to use chopsticks, and then they figure themselves out, and then now they can use the chopstick themselves. Okay, this obviously won't happen in China because pretty much everybody knows how to use chopsticks. But you see this happens a lot in like Chinese restaurant or Japanese restaurants in, let's say, Europe or the USA and things like that. Okay. Now, in terms of the observational learning, by the second half of the first year, the infant imitation they really start to become more robust. They can use things like facial gestures and sometimes even some strange actions. And the reason for that is because, I mean, it looks strange to us, but they're just trying to do some imitation that they have either seen us do as adults, and then they're trying to kind of copy it. And now at this age, they're actually able to reason the goal that behind the person's behavior, okay, of the person that they're trying to copy or imitate, okay. They meaning the infants, they can either do the same thing as the teacher, or they can use a different method to achieve the same goal. Okay, now your book also talks about the time when they get to about 18 months old, they can observe an adult attempting but failing to pull together a small dumbbell toy, as what you see here on the figure. Okay, now when the infants, when they kind of when you give the infant exactly the same toy, they try to pull they will try to pull the two ends apart, imitating what the adult had intended to do, but what he had actually done. Okay, so basically the research established that the infants in imitative actions are limited to human acts. They're not really doing that different things compared to the adult, but they was trying to do exactly the same thing that adult has used to do. Okay, and they might use a different method of doing so, but they can actually ration with they can come to a logical conclusion that this adult is trying to pull away the two ends of the dumbbell, and I'm gonna try to do exactly the same thing. But the method that I would do it may be different, but then that is the goal that I'm going to try to do. So this is observational learning really at its best, really trying to understand what the person's intention, what is their behind an action. Okay, so what is the purpose behind a person's action and why they're doing it, and when I'm doing it myself, how can I do it? Maybe doing it a little bit differently, but also achieve the same goal what this person is intended to do, but fail to do so. Okay, now what is rational learning? So rational learning is basically refers to the ability to use prior experiences to predict what will happen in the future. And we as people, we have a lot of beliefs about the world. And then I have to say that scientific reasoning is based on precise this sort of inferences from prior data. So basically, they use data that is have gathered before in order to make a prediction about the population. Okay, now and then they can use statistics to kind of infer what is going to happen. Okay, now what is now infants do this exactly as well. Okay, they can rely on the previous experience and then they would do this as a way to predict what will happen in terms of their expectations. Okay, now in this study, this thing on the bottom, what they demonstrated that 8-year-old infant could make predictions about simple events. And then, so the infants were shown a box containing about 75 ping pong balls, and then 70 were red and 5 were white. And then the infants then observed an experimenter close her eyes, okay, and then draw 5 balls from the box, either 4 red and one white, or 4 white and 1 red, okay, and put them on the display. And then, all right, so now the experimenter was actually drawing a pre-selected random samples from a hidden compartment in the box, okay? And then the infants, they're gonna do this themselves, okay? Now, then what happened is that when the infants, of course, when they are drawing these ping pong balls, the organization of that is actually going to be completely up to chance, right? They most likely there are going to be like 5 ping pong balls that were all red, okay? And then so what is going to happen is that these infants, when they get confronted with these violation of expectation paradigms, and then these infants, they are going to be really surprised to see that, well, how come this is not exactly the same thing that the experimenter pulled out, right? So what you can kind of see is that the infants, they can watch a person before, and then they can say that I think the same thing is going to happen to me. And when the things does not happen to them as expected, they are really, really surprised. Okay, so you can see that this is a way to really come up with, so this is the way that we also rationally learn about our environment. We use the prior experiences to predict what will happen in the future. But I just wanted to add this as a psychology professor, that if you really want to change your life, if you really want to make your life better, you have to remember that your past does not equal the future, okay? Just because in the previous 2-3 years you have not done so well, you should not let that dictate the rest of your life. You should always try to have a different set of beliefs that things are going to get better from now on, that nothing has gone wrong, and then you get to live the life that you truly desire for yourself. And don't let anybody else convince you otherwise. It doesn't really matter who. It might be your parents, it might be your friends that tells you. These are and something that's very interesting is that these are often like the naysayer in your life that will actually bring you down. You tell them about a dream and then they just shoot them down, and they just love to make you cry. And so this is something that I hope that just from this rational learning. So rational learning, I have to say that is a way that we kind of protect ourselves in the sense of that this is what give us certainty in life. Okay, but I have to say that this ability that you are relying on the prior experience also is going to hinder you from improvement in the future. Okay, so in other words, what I'm trying to say is that don't ever let other people telling you that you're not good enough. Don't ever let people make you believe that you are less than anything that you desire to be. Okay, so this is something that's really important. As a psychology professor, I'm telling you, you can be, do, and have anything that you want if you really believe it, but you have to really believe it, okay? And so with that said, I really hope that we will have a meaningful conversation in the discussion section that is coming up. Okay, so I am going to end the lecture here on a good note and then on an inspirational note. And I will see you guys in the Zoom meeting.